Okay, in lesson 11 and 12, we're going to be multiplying decimal fractions by multi-digit whole numbers using place value understanding to record partial products. It's kind of like just more practice of what we've been doing, except we're going to be focusing more and more on just abstract. We're not going to be using the area model much unless you need it. If you need it, you go ahead and draw the area model. In question 1, it says estimate the product, solve using standard algorithm. Use the thought bubbles to show your thinking. Now, here we're always going to do our estimate first, and we know we have 2 and 42 hundredths, and we're going to round this to the nearest whole number, which is between 2 and 3, and we can see it's 2 and 42 hundredths, so it's going to be closer to 2. 12 is between 10 and 20, and we're going to round that to the closest 10, which is 10. So we know our answer should be approximately 20. Now the little bubble here says think. 2 and 42 hundredths times 100 equals, should be 242. Now, the reason they're doing this is, the way I talked to you before, is that in order to get rid of the decimal, we would multiply by 100 because we want to move the decimal 2 place values. And that would make this 242. And then when we multiply by 12, we go 2 times 2 is 4, 2 times 4 is 8, 2 times 2 is 4. We're going to 10 times 242, so we put our placeholder. 1 times 2 is 2, 1 times 4 is 4, 1 times 2 is 2. So we add them up, our partial products, we got 4, 10, 9, 2,904. But see, we multiplied by 100 to get rid of the decimal. So that means we'd have to divide by 100. And we know that would shift the decimal 2 points to the left, and it become 29 and 4 hundredths. Okay? So we can see our estimate was 20, and our actual answer is 29. So it is reasonable. Now, they're saying think times 100 because they're showing you how to take the decimal out, basically. And then you have to put it back in by doing the reverse operation. Now, using estimation here for reasonableness, what we've done in the past, if we take 242 and we multiply it against 12, we just take the decimal out of it. When we multiply it out, we're going to end up with the same partial products. And we have 4, 0, 9, and 2. Then we look at our estimation. Our estimation is 20. The only place to put that decimal point to make it reasonable would be after the 9 to make it 29. So that is using your reasonableness with your estimate. Okay. Both of them are good strategies. Whichever one works best for you, that's what you should use. Solve using standard algorithm. Well, first thing we are going to do is we're going to do an estimate. So I have 2 and 3 hundredths, which I'm going to round to 2, times 13 is closer to 10. So I know my estimate is 20. So I know this is going to be approximately 20. So now I'm going to go ahead and strip the decimal out. We have 203 times 13. 3 times 3 is 9. 3 times 0 is 0. 3 times 2 is 6. It's 10 times 203, so I'm going to put the 0 down here so we can use our basic math facts. 1 times 3 is 3. 1 times 0 is 0. 1 times 2 is 2. So now we have 9, 3, 6, 2. So we have 2,639. But we took the decimal out. But if we look at our estimation, it's 20. So the only place we can put our decimal would be after the 6 for 26. Now it's a reasonable answer. On B, once again, 53, I'm going to round it to the tens, so it's going to be closer to 50 than it is 60. 34 is going to be closer to 30 than it is to 40. I know I'm going to have 2 zeros in my answer, and 5 times 3 is 15. So it should be approximately 1,500. So our answer here should be approximately 1,500. All right, so I'm going to take the decimal out. 5,316 times 34. 4 times 6 is 24. Carry 2. 4 times 1 is 4, and 2 is 6. 4 times 3 is 12, carry 1. 4 times 5 is 20, and 1 is 21. Put our placeholder in here, so we're going by 3 instead of 30. 3 times 6 is 18, carry our 1. 3 times 1 is 3, and 1 is 4. 3 times 3 is 9, and 3 times 5 is 15. Add up our partial products, we end up with 4. 8 and 6 is 14, carry our 1. 6 and 1 is 7. 9 and 1 is 10, carry our 1. 7 and 1 is 8, and 1. Now looking at our estimate was 1,500. So we know we have to put it at 1,807 and 4400ths. Question 3. Use a whole number product and place value reasoning to place decimal point in the second product. Explain how you know. And this goes right back to what we're using in the previous question. It says if 36 times 134 equals 4,824, then 36 times 1 and 3400ths equals, well, it's going to have the same digits, 4824, because we're multiplying the same digits against each other. Except this one here was 134, where this one is 1 3400ths. So if I did an estimation here, that'd be 36 times 1, or actually it'd be 40 times 1. So our estimation would be 40. So we know reasonableness, it would be 48 and 2400ths. Same here. The answer is going to end up being the same because we're multiplying the same digits, 224,616. But once again, if we did our estimation, we know this is 80 times 26 would be closer to 30. So our answer would have to be 8 times 3 is 24. It's going to be close to 2400. So the closest thing to 2400 would be 2246 and 1600ths. Question 4. A slice of pizza costs $1.57. How much would 27 slices cost? Well, the students should know by now I like area models. So I'm going to take my area model. I'm going to put this one piece here is $1.57. So every slice is $1.57. And I've got 27 slices. So this here, in order to solve this, I'm going to do $1.57 times 27. And that's going to have to give me total cost. So to do an estimation, 1 in 5,700 is going to be closer to 2 than it is to 1. 27 is going to be closer to 30 than it is to 20. So I know this should be approximately 60. So now I'm going to take my 157 times 27, just take the decimal out. 7 times 7 is 49. 7 times 5 is 35, and 4 would be 39. 7 times 1 is 7, and 3 is 10. Put our placeholder in here so we can multiply by 2 instead of 20. 2 times 7 is 14. Carry 1. 2 times 5 is 10, and 1 is 11. Carry 1. 2 times 1 is 2, and 1 is 3. Add up our partial products, and we see we have $40.39, well, 4,039. But we know our estimate was 60, so the only reasonable one would be 40.39. So total cost was $40.39. Question 5. A spool of ribbon holds 6.75 meters. A craft club buys 21 spools. What is the total cost of the ribbon? Sells for $2 per meter. Okay, so I know that this is important information because a spool holds that much. Craft, they buy 21 spools. What is the total cost of its 2 per meter? So my first plan, I need to solve for total meters of ribbon. And then 2, I need to solve or total cost of ribbon, because that's what it's asking for. It says what is the total cost if it's $2 per meter, and that's important information. So the first thing, I can see with a tape diagram that I have each one is 6.75 meters, and I have 21 spools. That means this here would be total ribbon, and that would be ribbon in meters. So this is going to be 6.75 times 21. So I'm going to go ahead and strip out the decimal. I'm going to estimate first, and I know 6 7/75 is going to be closer to 7. 21 is going to be closer to 20 it is to 30. So I know that's 140. So I know this should be approximately 140 meters. Now I'm going to go ahead and strip out the decimal. I got 675 times 21. 1 times 5 is 5. 1 times 7 is 7. 1 times 6 is 6. Put my placeholder in there. 2 times 5 is 10. Carry 1. 2 times 7 is 14. 1 is 15. Carry 1. 2 times 6 is 12. 1 is 13. So we end up with 5, 7, 11, 14, and 1. Now, we know it's supposed to be close to 140, so I know my decimal has to go right here. So we know the total length here now is 141.75 meters. Now they say it's $2 per meter. I'm going to use some of this room down here because I'm running out. So if it's $2 per meter, now I'm going to go ahead and put $2 here. And it's showing here that I have 141.75 meters. So when I solve this, it's going to tell me total cost. By looking at this, I can see this is 2 times 141.75. Now to do my estimate, it's already estimated at 2. 141.75 is going to be closer. It's either 100 or 200. It's going to be closer to 100. So we know that this has to be approximately 200. Now we have 141.75, and I'm taking out the decimal, times 2. 5 times 2 is 10. Carry 1. 2 times 7 is 14. 1 is 15. Carry 1. 2 times 1 is 2, and 1 is 3. 2 times 4 is 8, and 2 times 1 is 2. But remember, our estimation was 200, so we know this has to be 283.50 cents. So total cost of ribbon was $283.50. Now part B says if the club uses 76.54 meters to complete a project, how much ribbon will be left? Okay. Well, we come back over here and we can see that we have 140, we already solved for the total ribbon. Total ribbon was 141.75 meters. So we have 141.75 meters, and it says they used 76.54 meters. So I have to line up my decimal point. I'm going to subtract. 4 from 5 is 1, 5 from 7 is 2. I cannot take 6 from 1, so I have to regroup. Taking a 10 becomes 30, and this becomes 11. So 6 from 11 is 5. I cannot take 7 from 3, so once again I have to regroup, bring 10 over, and I end up with 13 minus 7 is 6. So they will have 65.21 meters of ribbon left. Okay, now we're going to go into lesson 12. Lesson 12 is more of the same. It's just that we're going to be doing 2 digits. We're having to the hundreds now. But everything's going to stay the same. We're still going to do an estimate. 1 and 2300 is going to still be closer to 1. 21 is going to be closer to 20. And we know our estimate is 20. So we're going to take the decimal out. 123 times 21. 1 times 8 is 8. 1 times 2 is 2. 1 times 1 is 1. But our placeholder, 2 times 8 is 16. Carry our 1. 2 times 2 is 4. And 1 is 5. And 2 times 1 is 2. So we have our 2 partial products. We're going to add the 2 partial products. And we have 8, 0 is 8. 6 and 2 is 8. 5 plus 1 is 6 and 2. Now our estimation was 20. So we're going to put our decimal right there. So now we know we have 26.88. Question B, 3.2. It's going to be closer to 3. 41 is going to be closer to 40. So we know this is going to be 120. So we have 32, 41. 1 times 2 is 2. 1 times 3 is 3. 4 times 2 is 8. 4 times 3 is 12. 2, 11, 3, 1. We know it was 120 was our estimate, so we have to put our placement or our decimal here for 131.2. Question E asks 609 is going to be closer to 6. 28 is going to be closer to 30. So we know this is going to be 180. So now we have 609 times 28. 8 times 9 is 72. 8 times 0 is 0 plus 7. 8 times 6 is 48. Add our placeholder. 2 times 9 is 18. We carry our 1. 2 times 0 is 0 plus 1 is 1. 2 times 6 is 12. 2, 15, 10, because we had to carry our 1, and 7, 1. Now we know our estimate was 180, so it has to be 170 and 52 hundredths. F, 6 and 83 hundredths is closer to 7. 683 is closer to 700. We know we're going to have 2 zeros, and 7 times 7 is 49. Strip out the decimal, 683 times 683. So we have 3 times 3 is 9. 3 times 8 is 24. 3 times 6 is 18, and 2 is 20. Put our placeholder, so we can do 8 times 3 is 24. 8 times 8 is 64, and 2 is 66. 8 times 6 is 48, and 6 would be 54. Now we're getting ready to multiply by our 600, so we're going to take 2 zeros out of there. So we have 6 times 3 is 18. We carry our 1. 6 times 8 is 48. 1 is 49. Carry our 4. 6 times 6 is 36, and 4 is 40. So when we add up all our place values, we have 9, 8, 14, carry our 1 is 10, 16, carry our 1, 6, and 4. And we know our estimate was 4,900, so it will end up being, and I gotta make that 6 better, 4,664 and 89 hundredths. Let me add that up, make sure that's 9, 8, 14, 6. Yeah, it was 6. Okay. Question 4. In our art galleries often price paintings by the square inch. Okay, square inch is important because square inch, that's telling me area. If a painting measures 22.5 inches by 34 inches and costs $4.50 per square inch, what is the selling price? So we know the 2 measurements are important. I need these. And it says $4.15 per square inch. So here is, I'm going to just do a quick little painting here. And we can see that this is 22.5 inches. And this one here be 34 inches. And we know area equals length times width. So we now have 22.5 times 34 to figure out the area. Well, to do our estimate, we know 22 is going to be closer to 20 than it is to 30. 34 is going to be closer to 30. So we know the area should be approximately 500 inches squared. So this should be approximately 500 inches squared. So now let's work it out. We're going to strip out the decimal, 225 times 34. 5 times 4 is 20, carry 2. 4 times 2 is 8, 2 is 10, carry our 1. 4 times 2 is 8, and 1 is 9. Put our placeholder, 3 times 5 is 15, carry our 1. 3 times 2 is 6, 1 is 7, and 3 times 2 is 6. And we did was 0, 5, 16, carry our 1, and 7. 7,650. Now we know it was approximately 500 inches squared, so our decimal place is going to go here. So we know the answer for an area equals 765 inches squared. Now, the question says, what was the selling price of the painting? Well, if I do my tape diagram, I know they're selling for $4.15 a square inch. And we just solved, said there were 765 square inches. So that's going to be 765 times 4.15. Our estimation, this 765 would be closer to 800 than it would be to 700. 4 and 1500 should be closer to 4. So we know that our answer should be close. 8 and 8 is 1632. Should be approximately $3,200. So let's come over here and do our standard algorithm. We have 765, and we're multiplying it by 415. We have 3 partial products. 5 times 5 is 25, carry 2. 5 times 6 is 30, plus 2 is 32. 5 times 7 is 35, and 3 would be 38. Okay, so the 5's done. Now we're going to the 10. 1 times 5 is 5, 1 times 6 is 6, 1 times 7 is 7. Now we're going to 400, so I'm going to put 2 placeholders so I can go 4 instead of 400. 4 times 5 is 20, carry our 2. 4 times 6 is 24, and 2 is 26, carry a 2. 4 times 7 is 28, and 2 is 30. Add up our partial products. We got 5, 7, 14, carry our 1. That'd be 4, 10, 17, carry 1, 1, and 3. Now, we know that our estimation was approximately $3,200. So our decimal point is going to come right here. So we know the cost was $3,174.75. Question 5. Jerry spends $1.25 each day on lunch at school. On Fridays, she buys an extra snack for 55 cents. How much money will she spend in 2 weeks? Okay, so let's go back to it again. Jerry spends $1.25 each day for school lunch. On Fridays, she buys an extra snack for 55 cents. How much money will she spend in 2 weeks? Well, this is one of those ones that you can really do a tape diagram real quick for. I'm going to do, there's 1 week, a snack, 1 week, and a snack. So we know this is 55. This is 55. Now over here, she said she spends $1.20 each day on lunch. So this is going to be $1.25. She goes to school 7 days a week. $1.25, goes to school 7 days a week. So Now I can do 125 times 7. I know 125, 1 and 2500 is going to be closer to 1 times 7. So she spends $7, or approximately $7. And that's going to be the same for both weeks. So now let's solve it and see what it actually comes out to. 125 times 7. 7 times 5 is 35, carry a 3. 7 times 2 is 14, and 3 is 17, carry 1. 7 times 1 is 7, and 1 is 8. So now we know it was approximately 7, so a decimal goes here. So we know she actually spends $8.75. $8.75. Now, we could either do this two ways. We can multiply them, we could add them. But here we have 875, 875, 5, and let's go ahead and add them up. 5 plus 5 is 10, carry our 1, 14, 15, carry our 1, we have to put our decimal place in there, and that's 1617. So 1750 is what she spends in 2 weeks. But it says she spends 55 cents extra on Fridays. So 55 and 55. 5 plus 5 is 10. 5 plus 10 and 1 is 11. So she spends an extra $1.10. We add these up and we have 0,681. So Jerry spends $18.60 every 2 weeks. Now there's different ways you could solve this with multiplication, but I believe just make it the easiest way possible.